Greetings. In this video, we are going to go ahead and talk about graphing square root functions and cube root functions using transformations. I want to remind you in this video that graphing square root functions using transformations, the very first step, always identify your A, your H, and your K. Your A, your H, and your K can then be applied to your parent function points, which are listed here, 0, 0, 1, 1, 4, 2, and 9, 3, and to find our new function. The other kind of key point here with graphing square root functions is I want you to see the similarity between square root parent function and its inverse, which is the x squared parent function, or a parabola, the quadratic function, right? So we only have half of it that we're going to go ahead and utilize. So here is our first example. We are asked to graph the function using the transformations to g of x. So again, like I said, the very first step that you should do is go ahead and graph or identify your a, which is -2, your h, which is -3, and your k, which is a +4. So this tells me that I'm going to have a x-axis reflection that we're going to vertically stretch by a factor of 2. Here, the h value, -3, it means I'm going to the left 3, and then k of 4, that means we have a vertical shift up 4 units. So there's step 1. Step 2, we're going to go ahead and transform our parent function points. So what I'm going to do is make a table here of our parent function points. So I'll call this x, and I'll call this f of x, where f of x is our parent function, root x. So just looking at my parent function points, 0, 0, 1, 1, 4, 2, 9, 3, and then we'll go ahead and make a second table. So x plus h, that is how you transform your x values, and then your y values are adjusted by multiplying by a and adding the k value. So I'll do the x values first, x plus h. So I'm going to subtract 3 from all of these values. 0 minus 3, that's -3. 1 minus 3, -2. 4 minus 3, 1. 9 minus 3, 6. Okay, and I'll apply the operations of multiplying by a to my outputs and then adding k. So 0, well, I'll just write it like this. So -2 times 0, which is 0, plus 4, which is 4. -2 times 1 is -2, plus 4 gives us 2. 2 times -2 is -4. Plus 4 results in 0, and 3 times -2 is -6, plus 4, which is -2. Okay, so based upon your kind of outputs here, you want to depict a good graph. Our points are kind of fine here, so I'll write a standard x, y axis here. And we'll go up by 1 unit and left, right by 1 unit. Okay, so my first point, -3, 4, so -3, 4. -2, 2. 1, 0, 1, 0. And 6, -2. So 2, 4, 6, -2. And kind of some key points here when you connect this curve. Your very first point is your starting point. Okay, so don't put an arrow. Like there's nothing this direction. Okay, so we'll start here, and I'll do my best to attempt a smooth curve. Okay, and you have an arrow, and I mentioned this, and it says it in the notes. You want a smooth curve. Okay, so it's not connect the dots. And if you're curious, go ahead, graph this function on Desmos. So check that out for kind of just how this should look, and that's what we should get, right? Obviously with the arrow down here. Okay, so that is graphing square root functions. We'll do the same thing for cube root functions. Just the only thing that's different after finding our a, h, and our k is we will use the parent function f of x equals cube root of x. Okay, so the cubic root of x, remember the parent function f of x equals x cubed. So this is a cubic function, right? Looks like this, and its inverse, which is the cube root. I'll change this to a g of x so we don't have any discrepancies. It's a g. So it kind of looks like it's tipped on its side. So it'll look something like this. Okay, so let's go ahead and check out this example here. In this example, we will have an a value of 1/2. You'll have an h value of -2, and you'll have a k value of -3. So looking at here our function g of x, I'm going to go ahead and first write down our parent function points. This helps me. I get kind of confused with all the different points floating around. I like to identify what's my parent function first. So I say f of x, and I also like to identify f of x is equal to cubic root. I almost wrote the 3 there. Cubic root of x. So those points are -8, -2, no, not -2. That's the output. -1, 0, 1, and 8, and the output is -2, -1, 0, 1, 2. So let's go ahead and transform. Again, x plus h, ay plus k. And this works for anything. Are you talking about quadratic functions? Are you talking about cubic, quartic functions? Even logarithmic functions apply. You can go ahead and transform all of these with a, h, and k if it's broken down in this form. So x plus h. So -8, take away 2, -10, -1, -2, -3, 0 minus 2, -2, 1 minus 2, -1, 8 minus 2 is 6. Pick up. Okay, so we'll go ahead and we'll apply now our outputs. I'll take half of each value and then I'll subtract 3. So -2 times 1/2 is -1. Minus 3 is -4. -1, half of that is -0.5. Take away 3, -3.5. 0 times 1/2 is 0. Take away 3, losing space. It's -3. 1/2 of 1 is 0.5. Take away 3 is -2.5. And 1/2 of 2 is 1. Take away 3, that's -2. Okay, so let's go ahead and graph this. Notice, based on our points, these are all negative. All negative. I need to fit -10 and then 6. So I'm going to put my y-axis roughly here. Let's hope that fits it. I believe it should. All right, 1, 2, 3, 4, 5, 6. Okay, we're good this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're good. And then all these values are negative, so I can put my x-axis up here. It's a good idea to label, right? This is x-axis, this is the y-axis, and then definitely, yes, you have to, -2, -4. Just give the reader or whoever is looking at this kind of an idea of what the units are. So, -10, -4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go down 4 to this point. -3, -3.5. 1, 2, 3, down 3.5. It should be here. -2, -3 is here. -1. -2.5 is here, and 6, -2 is roughly here. So here's your function, and again, a smooth curve. Remember, for cubics, check this out on Desmos, your parent function. So I'll go through this point, and I'll slightly curve through here, and then go through that point. Okay, so that's an example of graphing cube root functions. Please try the practice problems that are in a PDF in Google Classroom. If you have any questions, please feel free to email me. Like, subscribe, do all that great stuff. Make me YouTube famous. All right, Schwarberg out.